Welcome everyone, and thank you all for joining. This is our 12th meetup and the first for this year. We are actually turning 1 year old today, so happy birthday to us. For who is new in the meetup, my name is Cristian Angel, and I will be your host. And we have the great honor today to have Nikola Ilic as our special guest. We'll go through some slides at the beginning, some organizational stuff, only a few slides, and then we'll go through with the session. So we are in the welcome and overview part right now. As I told you, it's only a few minutes. I'll show you what's the next meetup. Then Nikola will have his demos in the session. Then we can have a live Q&A in the end, but feel free to use the chat during the meetup. Then after the live Q&A, just before wrapping up, we'll have the monthly raffle from Enterprise DNA, and then the wrap up, and maybe we can stay a bit more after we stop the recording. For the ones that are shy, after we stop the recording, we can go live and have some chat and some discussions, either on Power BI or something else. Please make sure that during Nikola's session, your microphone is muted and your video is turned off. As I said, if you have questions, please type them in the chat with a Q in front so we can spot them easier. And if you have problems with the internet connection, please drop off and join again. And the same thing is available for me also. The meeting is recorded, so the recording will be put probably during the weekend on our YouTube channel. So our next meetup will be with the first Romanian speaker, with Cristian Prifti, which is here with us. I'm looking forward to it, and I'm sure this will be a great session. Even if it's a Romanian speaker, the session will be in English, so that our other users will be able to understand and attend the session. Then we will have meetups every month on the last Thursday of the month. I think someone is not on mute because I hear myself. So I'm looking forward to our February meetup on the 24th. And then, as many of you know, since last year in August, we have a great partnership with Enterprise DNA, which became our primary official sponsor. We are sponsored on every meetup with 3 full annual Enterprise DNA membership licenses, which now includes 3 annual Analyst Hub memberships. So whoever is attending the live meeting is able to participate in a raffle just by filling up this form. Don't worry, I will paste the link in the chat after Nikola starts, but feel free to scan or copy the link. So in the end, we will have the raffle for the winners, and until then, let's welcome Nikola Ilic, who is a friend of mine, and actually we've met through Power BI community. We've never met in person. We were actually really close to meet 2 weeks ago in Salzburg, but when I was in the area, Nikola was not there. Nikola is an MVP, an MCT, a plural site author, blogger, speaker to a lot of conferences. I've learned a lot from his other sessions and from his blog, datamozart.com. By the way, you should check out the blog because he started a very cool series with Tom Martens. Nikola, please tell us a few more words about future plans that you have, because I know you're having some plans for the future, and then the stage is yours. Thanks again for accepting the invitation.
Thanks, my friend. And yeah, really pity that we didn't meet in person. here in Austria, but I'm sure that there will be a chance either here or maybe in Romania or maybe at some conference somewhere.
Yeah.
Who knows? Yeah.
Maybe SQL bits. Let's see.
Let's see. Yeah. First of all, thanks for inviting me. It's really, as I said, I'm honored to be part of this speaker lineup for the Romania user group. And first of all, happy birthday to your user group, and I wish you many more years and many more successful sessions. Regarding plans, yeah, you did the introduction better than I would do. So regarding plans, now I'm joined with Tom, who is really one of the top experts in Power BI and DAX. We are creating this data modeling series. We have some rough ideas in which direction it will go. Of course, I can't,
reveal too much.
Yeah, too much. Yeah, of course. But I mean, it's not a secret, but we are tuning this along the way. So basically, we have some set of predefined topics that we want to cover, but also if we remember something in the meantime, we will expand on this. So these are the plans for the next months. Of course, continue blogging and speaking. So now that's my main focus.
I don't know how you do it. How do you have the time to do everything?
Yeah, so for me, Power BI and working with data, it's like a hobby. So I do this also in my spare time. So, and good organization, that's I would say the key thing is to be well organized and plan everything ahead, and then it's not a problem.
Yeah, cool.
Okay, if you don't mind, I will start a presentation.
Please.
Okay, so here we are, and once again, hi, good afternoon, or good morning, or good evening. I don't know, with these virtual sessions, people are joining from all parts of the planet. So welcome to Romania Power BI and Modern Excel user group meeting. Before we start, I will just briefly repeat what Christian already said. My name is Nikola Ilic. I'm originally from Belgrade in Serbia, but I live in wonderful city of Salzburg for last almost 6 years, where I work as a manager analytics for Avanade, joint venture company of Microsoft and Accenture. Other than that, Christian told already everything, so I will not waste time explaining. You can find me on web, on social media. Feel free to connect if you like. I would just add that privately, I'm father of 2 kids and true football and Barca fan, as you can conclude looking at this photo on your screen. Okay, so let me be honest.
Everybody knows you.
Yeah.
In the community.
Let me be honest with you at the very beginning. So creating a Power BI report may look like an easy task. So you connect to data source, you import the data, you set those nice colorful visuals, and your shiny dashboard is ready. But one day you receive a phone call from the report user who complains that her or his Power BI report is slow. Or what's even worse, your scary old DBA walks into the office and asks you to explain why your report burns all the available resources during the data refresh process. In the end, no one comes to you, but simply your report works slowly and it's annoying for everyone. As I've already told you, creating a Power BI report is not a rocket science, but in the end, there is a huge difference between a Power BI report that just works and a Power BI report that works efficiently. Now you're probably asking yourselves, if I have performance issues with Power BI, where do I start? And that's a great question, because once you identify the area that causes the problems, you are halfway through the solution. Okay, maybe not the halfway, but you can then shift your focus to finding a solution to a more specific issue. And when we are talking about specific issues, there are at least 5 key areas to examine if you want to improve the performance of your Power BI reports. So let's go and check what are these 5 areas. First one is the data model size. Next is data refresh process. Next, of course, DAX calculations. The fourth one is visualization rendering time. And finally, storage mode choice. So we will now go and try to understand each of these areas in more depth. I'll try to show you some potential caveats and how you can avoid or overcome them with some workarounds. And I will also try to share some best practices from my experience for getting the maximum performance from your Power BI report in multiple different scenarios. Okay, so the first thing I would like to discuss is your data model size. It is so important that in certain scenarios, for example, when you are operating on Power BI Pro license, which has a 1 GB limit per data set, your solution simply can't be used if you reach that limit. Data model size also affects our second talking point, you will see later, data refresh process. As you may assume, the larger the model, the more time and resources are needed for the data refresh. Basically, tabular model, which is in the background of Power BI, and its speed is based on keeping data in memory, in cache memory. Thus, the smaller the memory footprint of your data model, the faster it will work. Now, to understand what affects data model size, we need to, dig a little bit deeper and to lay some theoretical background. First of all, when you choose import mode for your data in Power BI, data is being stored in a columnar database, which is called Vertipack. Vertipack keeps the snapshot of your data in memory. And this snapshot then can be refreshed periodically from the original data source. To understand how things work in the background, of course, I will not go into details. Now, there are multiple sessions dedicated exclusively to Vertipack engine, and Marco and Alberto had a lot of sessions and videos on this topic. I'll just cover some basics. So you should be able to distinguish between formula engine and storage engine. Those are two key components of this underlying architecture. You can think of formula engine as a brain of Power BI because it translates DAX to a specific query plan, and that query plan consists of different physical operations such as joins, aggregations, filtering, and so on. Then storage engine represents the muscles of Power BI because it physically goes through the data which is stored in tabular model and pull the data for you. So if storage engine needs to go and dig through massive amounts of data, it would obviously need more time and resources. And I'll try to give you a simple analogy. Imagine you have to find a book in your old attic. And what do you think? Would it be faster and easier to find it if you have just a few items around, or if your attic is in complete mess and full of all kinds of stuff? I think you know the answer. So optimizing data model size is a very wide topic that I also have a separate session dedicated exclusively to this topic, so 60-minute session. So let me just here quickly list best practices related to a data model size optimization before I show you a quick demo how it looks in reality. First and most important rule is reduce the data you are importing in your data model and keep only those, not just columns, but also rows your users really need in the report. That means remove unnecessary columns, remove unnecessary rows. How do you remove unnecessary columns? That's quite, I don't need to explain this, but how do you move unnecessary rows? Check with your users if they don't need data from last 5 years, but only 2 years, then simply don't import it. Next one, also very important, try to reduce column cardinality whenever possible. Cardinality means the number of unique values in the column. And in most cases, Vertipack applies special compression type, which is called hash encoding, and build a dictionary for distinct values in your column. So the lower the cardinality, the smaller the dictionary, and consequently it will take less memory. So if you don't need data, let's talk now about a real use case. So if you don't need data on a level of granularity lower than day, then just simply remove time portion of the data, and that will significantly reduce the size of that column. I'll show you, as I said, in a few minutes in one example, what I'm talking about. Next, avoid using calculated columns whenever possible, as they are not being optimally compressed. Instead, if you need to do some calculations, try to push all calculations to a data source, like SQL database, for example, or perform them using Power Query Editor. Disable auto date time option for data loading. A lot of us didn't know that when we started using Power BI. This is by default, this is enabled. And once you disable it, this will remove a bunch of automatically created hidden data tables in the background. Instead, always create a proper calendar or date dimension in your data model. Okay, so let me show you one of these points in action, and I will go quickly to Power BI Desktop, and here I have a date time column that goes to the second level of granularity. I will show you now. Here, that's data about chats performed by customer support department, and as you see, this date team start UTC column shows me the date and time when a specific chat happened. Okay, and I have, as you may saw here, I have almost 9 million distinct values in this column. To be able to follow what is going on with the data model and different metrics behind my data model, I will use DAX Studio. For those of you, I sincerely hope that all of you are aware of DAX Studio, which is fantastic free tool, same as Tabular Editor. DAX Studio is created by Darren Gosbell, guy from Australia, and it has a whole bunch of very useful and cool features that will significantly boost your Power BI development. So you can grab it for free at daxstudio.org. And if you have it installed on the same machine as Power BI Desktop, you can launch directly DAX Studio directly from Power BI Desktop. So I went to external tools and I opened DAX Studio instance that will automatically connect to my data model. One of the features that I'm using most in DAX Studio is VertiPack Analyzer. So VertiPack Analyzer basically collects different metrics behind your data model from dynamic management views and collects everything and serve everything to you in more readable way. So you can go to SQL Server Management Studio and write those queries to retrieve the data, but this is much more user-friendly and more structured and more readable. So use DAX Studio for this and VertiPack Analyzer. Now, if I go to this advanced tab on the top and you see this View Metrics button, I'll click on it. And after a few seconds, I can see different figures here in this main window in the middle. Let me just briefly walk you through. Cardinality is the number of distinct values. This is the maximum number of distinct values within the table. The size of the table, column size, etc., etc. Those numbers are in bytes, just to be clear. So you can see that this chats table, if I click on this small arrow, I can see all those numbers on a column level. And we may see that our data team start UTC has almost 9 million distinct values, 8.8 million. And size of this column is 454 megabytes. 454 megabytes. Please remember this number because something will change after we apply some optimization on our data model. You can see that dictionary size takes almost, I would say, I don't know, 80% of total column size. That's the thing that VertiPack built in the background using hash encoding, which you can see here. And this column takes 82% of the whole table and 46% of the whole data model. So this is really huge column. Now, if I go back to Power BI Desktop and let's open Power Query Editor, I will just get rid of time portion of the data. In 95% of cases, I would say, okay, so something is okay. Let me just pull this again. Maybe it's okay. Instance failure. Okay. Let's go back. I'll go back here later to this, so we don't waste time. I don't know what happened, so probably I switch a data source path. But in the end, once we removed a time portion of data here and relaunch VertiPack Analyzer in DAX Studio, we will save approximately 85 to 90% of the memory. So instead of having a column of 454 megabytes, this column will take around 6 or 7 megabytes. And cardinality of this column, instead of almost 9 million, will be slightly more than 1,000 distinct values. So as I said, try to reduce the cardinality whenever you can, as that will enable VertiPack to compress the data more efficiently. Okay, so going back to the first demo, where we had I will open Deck Studio again. Almost 9 million distinct values in this date time UTC column. Let's open again VertiPack Analyzer. And here is the column 454 megabytes. Okay, now if we go to Power BI Desktop, this is the column I want to change. This one, date team start UTC. I will just change type of this column from date time to date. So basically I will just get rid of time portion here, hit close and apply. Okay, we need to wait some time. Hopefully it will not take long. And it should bring a significant saving in terms of space. And of course it will speed up the calculations and everything else. Oh, come on, this took quite longer than usual.
The end result matters.
Yeah, so we have here 454 megabytes, and I did this in real life cases. I did this in, I don't know, almost every report. Just getting rid of those seconds and minutes. Even though if you need them for some kind of reporting, what you can do, of course, this one is not so big. I mean, still half of gig is not to raise the alarm, but if you have a fact table with 200 million rows and you still need to do some reporting on hour level, minute level, or whatever, what I did was splitting date and time in separate columns. That also reduces cardinality.
Mm-hmm.
That's also another option for reducing cardinality. So basically you get two columns, but both with lower cardinality, and in total you have lower memory consumption. But then you need to rewrite the measures. That's the trade-off.
Yes, and you need a separate table if you want with dimensions for time.
Yeah.
If you want to report by time.
Yeah.
This is coming back to your discussion and your point on cardinality. Do you really want it by the minute? If
exactly.
You want it only by the date, you just remove the time and keep everything by date, and you are reducing the cardinality.
Yeah, that's significantly reduced, because I saw many times, and I was also doing that in the beginning while I didn't know the implications. So I was just importing, tables as it is from database.
From SQL.
Yeah, from SQL. Just put the whole table, each column, how it is in database. Let's put it in Power BI. Yeah, and yeah.
I know the feeling. I was doing it the same, and at the beginning I was not even aware of query folding, and I was happy that I could write my own SQL statement at the beginning, and I was just putting the SQL statement, breaking the query folding from the beginning, and this was it.
Same here. I was even using store procedures to retrieve the data.
Yeah, I know.
Okay, so finally, yeah, we have now, instead of 9 million distinct values, we have cardinality of 1,356. Let's confirm this here. I will refresh and open again. So it's, let me find this column. Okay, here it is. Date team start UTC 1,356, and now it's 9 megabytes instead of 454. It's just 9 megabytes. So it's 90% lower just by changing data type. We didn't do anything else, just change data type and reduce the cardinality. Okay, now that you know how to optimize your data model size, your data refresh process will run much faster. And that's true, but not in 100% of cases. I mean, if it's simple as that, this session wouldn't have existed. So as I've already explained, VertiPack keeps the snapshot of your data in memory, and you are then refreshing this snapshot from time to time depending on your specific business needs. You can refresh your data once per hour, once per day, once per month, and so on. Now, chances are that you're applying some transformations to your data before you load it to Power BI. That can be a currency conversion, that can be data filtering, renaming your columns, performing some calculations, stuff like that. So where do you shape your data? First, source database. That's the most obvious choice if you have a possibility, of course. And in most cases, that's the most desirable scenario, which is based on traditional extract, transform, loading processes, or ETL abbreviated. If you don't perform your transformations, your data transformations on the data source side, the next station is Power Query. Power Query is the built-in tool within Power BI that enables you to perform all kinds of transformations to your data. According to Microsoft's official documentation, last time I checked, you can apply more than 300 different transformations, and that number is constantly increasing. The key advantage of Power Query is that you can perform complex data transformations with little or no coding skills. So you're just simply clicking, dragging, and in the background, everything is done for you. Of course, you can hand write M code to enhance your transformations, but that's a whole different story. Keep in mind that all steps you apply during the data transformation process are being saved. So every time you go and refresh your data set, those steps will be automatically applied to shape your data and prepare it for consuming via reports in Power BI itself. Under the hood of Power Query is a mashup engine that enables your data shaping process to run smoothly. And Power Query uses, as I already mentioned, very powerful M language for data manipulation. Now, for some data sources, such as relational databases, but also for some non-relational sources like OData or Active Directory or Exchange, Mashup Engine is able to translate this M language, so manipulation language of Power Query, to a language that this underlying source will understand. In most cases, it will be SQL. What's the idea behind this? By pushing those complex calculations and transformations directly to a source, Power Query leverages capabilities of those robust relational database engines that are built to cope with large volumes of data in the most efficient way. And that ability of Power Query's mashup engine to create a one single SQL statement that combines all M statements behind your transformations is what we call query folding. Or let's try to make it simple. If the mashup engine is able to generate a single SQL query that is going to be executed on the data source side, we say that the query folds. Query folding is an extremely important feature in Power BI. I always like to quote Ben Watt, my friend who runs Power BI user group Dublin. He calls query folding unsung hero of Power BI, and that's completely true. Many people are not familiar with the concept of query folding, especially beginners, but that's one of the most powerful features in Power BI. So I'll show you a quick demo how query folding may affect your queries. Let's go back to Power Query Editor. Okay, so here now I have my table online sales filter, which comes from Contoso sample data set, and it has around, I think, 12.6 million rows in total. Now I will go and apply some transformations to my, or let me show you. So data refresh, yeah, we have 12.6 million rows. Okay, and now I will apply some transformations here in Power Query Editor. So let's expand dim customer table, and I'll grab first name, last name, and gender from this table. Then okay, I have problems with SQL database. I think I know what's that. Sorry about this. I was shrinking log files and forget to build again. So, okay. I'll go back to let's move on, and I will fix this by the end of the session. I will fix this and show you the demos that I prepared
No problem.
Really apologize about this. I completely forgot that shrinking log file may produce problems for Power BI also, not just for SQL Server. The other demo is for query folding. So I'll do this quickly just to turn off. I'm not sure if I turned off this data preview in the background. Yeah, definitely something is wrong with Power BI. You see how it doesn't react. Okay, data load, allow data preview. Yes, I forgot to. Okay, and let's now go again to transform data. Okay, this one I'll take just some simple transformations just to show how it looks without and with query folding. So first name, last name, and gender. Okay, I'll do uppercase or of first name. Okay, then let's do filtering. I'll do total cost is greater than. Oh, come on. Yeah, something is definitely not okay, but never mind. Is greater than, let's say, 5. And now I will break query folding in the next step. Okay. Or let's first do with query folding. So I will change data type like I did in the previous demo from date time to date. So I will just remove time here. And let's now do, for example, I don't know, sales quantity. I'll do something stupid like absolute value. Never mind, it doesn't make sense, but just to show the implications. And let's do replacement here for gender. Oops, I'll replace value M with male. And finally, let's do some other filtering. So I'll go to sales amount and let's keep only rows where sales amount is greater than 500. Okay. So how do you check query folding? Right click on the last step. If this view native query option is enabled, that means that query folding is happening. And you can click on it and see the SQL query that is being generated and sent to a SQL database. And you see all our transformations here. So we are converting date time to date. We are calculating absolute value. We are uppercasing, replacing M with male. But the most important thing with query folding is this. I'll show you why. This here. So we have where clause. Total cost is greater than 5 and sales amount is greater than 500. Why? Because in this case, data will be filtered on the SQL database side, and we will get. Let's go back to Power Query Editor. I'll close and apply, and we'll see how many records do we get here. So let's follow what's going on, and while data is loading. But if there is a chance to avoid breaking query folding, that's good to keep in mind that something can break query folding, that the query folding exists. But if you have to do it, yes, you have to do it. This is something. There's something this definitely wrong. Let me try to. Okay, finally. Okay, so we have 1.5 million rows. Now, if we go back, I will break query folding. So now you saw the final query here with all those where clauses and everything else. So here I will just delete this step. But I'll do exactly the same. So I will remove time portion, but instead of change type, I will use transform and select date only. So basically in the end, I'm getting exactly the same outcome. No time here, just a date, but this this step broke query folding, my view native query option is disabled. This should be the last one. Yeah, the last step that folds is this filtering. And if I go, oops, not this one, sorry, let's revert it here. If I go and check my last step that's foldable, you see that this where clause that includes sales amount greater than 500 is omitted, so it doesn't exist. No absolute value calculations, etc., etc., and that is something that will affect performance in terms of. Let's hit close and apply, and let's wait for a few moments. Something is definitely not okay with Power BI Desktop. It shouldn't work so slow. Okay, you will see the problem. So we know now that we need to have 1.5 million rows or something like this, almost 1.5 million rows. But look what happens now. So it loads the data, and now you should expect to stop at 1.5 million rows. Oh, it stops. Something is again different, I think, in approach, because you saw that this where clause was not in SQL statement. Yeah, query folding is really interesting stuff. As we didn't have this, I'm not sure if it's pull something from cache or what, but we didn't have where clause for a sales amount greater than 500. Yeah, so I'm not sure. Yeah, maybe that did something in the meantime. Yeah, in any case, for query folding, if you have something like this which breaks query folding, put it down there below, because now in this case this step will be foldable, and all your transformations and all your filtering and everything, you see this sales amount 500 is now here. All your filtering will happen on the data source side, and then Mashup Engine will have way less work to do to shape the data for the report. Okay, so going back to our presentation, and yeah, listing all the best practices related to data refresh process would be complex task. Therefore, if you identify that your data refresh takes a long time to execute, maybe it's a good idea to check it. And the first thing I'm going to recommend here is a fantastic blog post from Phil Seamark at dex.tips, where he explained how you can visualize data refresh process and quickly identify potential bottlenecks. Some general best practices in order to speed up data refresh process in general and keep query folding in place would be, first and most important one, push calculations and transformations as close to your data source as possible. For example, if you have permission to create a database objects, you can encapsulate all the necessary transformations in the database view, and then you can import that view in Power BI. Views, same as normal tables, are foldable objects, so you can even apply additional transformations over this view. Query folding is not all or nothing operation, and that means if you have, let's say, 7 or 8 different transformation steps in Power Query, and your query folds until 5th step, you will still get some benefit from this partial query folding. However, once the query folding is broken, it can't be achieved anymore. So keep that in mind. Even though you apply some foldable transformations after this step that breaks query folding, those transformations will not be executed on the data source side. Keep that in mind, as I said, and try to push all non-foldable steps down this transformation pipeline as much as possible. So what I'm talking about, if you have this transformation, try to move it here. So as down to the bottom as possible. Also, this one is also important. Turn off allow data preview to download in the background. Why should you do this? Well, when you are in Power Query Editor, you see preview of the data for every transformation step you applied. So when you hit the refresh, it's not only the amount of data that gets loaded into your data set, but also many different queries to refresh this preview. And in some situations, these queries take more time than loading data itself. Just one disclaimer here, this is happening, this thing with allow data preview, this is happening only in Power BI desktop, so no, not in service. If I have to choose one single rule regarding data refresh process, and let me call it the golden rule, that would be, many of you are familiar, Christian, I know that you're familiar with this one. It's not my sentence. I picked that from Matthew Roche, and this is famous Roche's maxim. Push transformations and calculations as upstream as possible and as downstream as necessary. Keep that sentence always in mind, nothing else to add. Okay, so now hopefully we are done with the background problems and we are slowly navigating to a user interface. And honestly, that is the area of Power BI where performance issues are the easiest to spot. And I'm sure that sooner rather than later, someone will come to you and say, hey, why is my report so slow? Of course, there can be a whole bunch of potential reasons, but let's focus on a few that are most often guilty or responsible for the bad user experience, which is caused by slow reports. So once you import the data in Power BI, I assume you will start writing DAX measures to satisfy different business requests. For example, you need to provide your business decision makers with the metrics such as the number of unique customers, top performing products, running total of the sales amount, and so on. The beauty of DAX, and I intentionally put this word beauty under the quotes, is that you can achieve the same result in multiple different ways. Of course, I will definitely not go deep into DAX logic in this session. I consider myself as an average DAX user, so but I want to share a few situations, few examples that I faced during my work with Power BI, where really little nuances in your DAX formulas can take you in a direction that you wish to avoid. So let me show you. I think this demo should work. Let's hope for that. If not, I promise I'll fix this during the raffle or something like this and show you all the demos I prepared. Okay, so the DAX example, I want to show only orders, only huge orders, only big orders. What are big orders? All the orders where the sales amount is greater than 500. Okay, now I will go to DAX Studio and let's launch a new one, a fresh one. Okay, and I will write first this measure in this way. I will explain everything until the measure is running. So I'll turn on server timings so I can follow what is going on in the background and check specific queries that are being sent to an engine. And I will hit clear cache and run. Okay, now we are waiting for this query to be executed. You can follow here in the bottom right, you can follow the elapsed time for this query. And while we are waiting, I will try to quickly explain what is happening here and why this measure is running slow, because obviously it takes already 20 seconds to return results. In the end, it should return correct results. And yeah, remember, performance is important, but it is even more important to have correct figures in the end. So what's wrong with this measure? Why is it so slow? So if we take a look at, okay, it's done, 34, almost 35 seconds. So we'll go to results and yeah, that's it, server timings. So you see almost, let me zoom it a little bit, almost 35 seconds to return results. Why is this happening? So basically we had here 1097 queries. Each of these queries are quite fast. You see 30 milliseconds, 27, 25. Each of them is fast, but there are more than 1,000 of queries. Basically, what Formula Engine did here, for every materialized table of data that was returned by storage engine, it ran a distinct count against each set of data which was specified in our filter condition for each date. So we had 1097 dates in our data model, so one query was ran for each date. That happened because we provided here a table as an argument for the filter function. I'll show you now the second definition of this measure, which should run faster, hopefully. So let me just grab it here and let's put it below so we can compare the results. I will again hit clear cache and run, and let's wait for a few moments. Now it's 150 milliseconds. And at first glance, those two queries look pretty much similar. So we are using distinct count, we are using filter function in both situations, we are using filter function. But this one, instead of running 1000 and something queries, this one ran only one query. Here in the first example, in bad example, as a first argument of filter function, we provided a whole table, whole online sales table, fact table with 12.6 million rows. And then we perform filtering to keep only those rows where sales amount is greater than 500. Here, basically, we are removing all the filters, all the active filters from online sales table, or sales amount column from our online sales table, and then we apply this filter only on this one single column. That's why this one works so much faster. The third way to write this measure is like this. Let me put it below. This one is also this is just a syntax sugar. Basically, I've omitted this filter all syntax here, but in the end, when you run something like this, what Vertipec will do Vertipec will implicitly add this part of the code to your measure. Nevertheless, if you haven't written it, the Vertipec will add this and execute exactly the same query. It's 123 milliseconds. That's almost the same, but the query is exactly the same. And now you remember when I told you that beauty of DAX is that you can achieve the same result in I don't know how many different ways. I will show the fourth definition of this measure that will return exactly the same results. This time, instead of using filter, we will use keep filters function, which is different than filter function, but in our case, this should return exactly the same result. Again, we are getting results in 72 milliseconds. Don't pay attention to this number 72 milliseconds, 120 milliseconds. That's irrelevant. But comparing to 35 seconds that we had in our first run, this is a significant improvement. And here with keep filters, we get exactly the same query as in the previous two cases with calculate and with the filter all. Okay, so the next thing I want to talk about is, that's the most obvious problem. When your report page renders slow, you can bet that the report consumers will come to you and complain about poor experience and ask you to do something. So let's check what can be a root cause of the slow rendering. First of all, Power BI Desktop offers quite a handy built-in feature which is called Performance Analyzer. Performance Analyzer enables you to capture performance metrics for every single visual element on the report page. And of course, the rule of thumb is the more visuals you have on your report page, the longer time would be needed to render the page. And I'll show you in a few minutes how this looks in reality. Okay, so here I have 10 card visuals displaying different metrics from our Contoso effect table. Very, very simple measures, so nothing fancy, nothing complicated. Average, max, minimum, sum, so quite simple DAX measures. So first thing I'm going to do is to turn on Performance Analyzer. Under View tab here, you see this Performance Analyzer option. And I'll start recording. Now, if I hit Start Recording and refresh visuals, there are different metrics that Performance Analyzer captures. So I'll try now to sort report elements by total time and in descending order and quickly identify the slowest one. So let's go and sort this by total time in descending order. You can see that this card, I don't know which one, this one, total unit cost was the slowest one, took 643 milliseconds to render. If you click on this small plus button here to expand this information, you can see the DirectQuery took only 17 milliseconds, which is quite fast. Visual display also some trivial value of 12 milliseconds, but 95% of the time was spent with the other. Now you're probably asking yourself, what the heck this other means? And this is a great question, so let me answer it. Other means how long did specific visual had to wait for other actions on the report page to complete before it could be handled. So don't forget, Formula Engine works in a single threaded way, so it can't generate the DirectQuery for multiple visuals in parallel. In this case, this card was slowest and had to wait 614 milliseconds for other cards to render and complete. And I want to show you now this same example on the other report page. Let's clear this and stop. So I have exactly the same look of my report. Credit goes to Chris Hamill from Microsoft for this idea to substitute card visuals with basically those are two matrix visuals, with spending some time and effort to properly format everything. We get exactly the same look as in the previous page. But this time, instead of having 10 cards, we have exactly the same measures here. Now we have just two matrices, and let's see if that changes something in the performance. I'll refresh visuals, and you see that our matrix took 240 milliseconds. Now with this, it's like 3 times faster than in the previous case. And as I said, these were really basic and simple DAX measures. You can imagine the impact and order of magnitude in difference for complex measures and for models or report pages that have even more report elements on the page. So basically, instead of generating 10 separate queries, which we had in our situations with cards, Formula Engine now was able to generate only 2 queries to retrieve all the data we asked for. And that obviously reduced rendering time for our report page. Similar outcome can be achieved with a free custom visual card with states from OKViz, which you can also download from the App Source Marketplace. But if you don't want to mess with the custom visuals, you can use good old metrics with proper formatting to achieve exactly the same result. Okay, so here is the list of things you should do or not do when it comes to performance of your visuals. First, reduce the number of visuals on your report page. If you don't need a visual on the page, simply remove it. Also, having multiple non-data related objects such as shapes or text boxes will also have an impact on your rendering time. So each element needs some time to render. Therefore, if you plan to have a lot of shapes and text boxes, images, icons, stuff like this, consider using PowerPoint. What you can do in PowerPoint, you can create your desirable page design with all those elements, with all those shapes, icons, I don't know, whatever. Save this as an image and then set this image as a page background in Power BI. That way, instead of having, I don't know, 15 different elements on your report page, you will have just one. Next, reducing the number of visuals on your report page also means that, like in our example, if you have a possibility to satisfy the business request by generating 1 DAX query instead of 5 or 2 instead of 10, like we had in our demo, you should tend to do it whenever possible. Also, try to display data at a high level of granularity. What this means. Vertipack is brilliant in vertical aggregations, but performs much worse on a detailed level reporting. So with that in mind, if you have, let's say, a table with 40,000 rows and some measures being calculated for each row, you should be better off keeping this low level detail by taking advantage of, for example, drill through feature. So go and display aggregated data in the table by default, and then give your users possibility to drill through to specific row if necessary. If you have a lot of visuals on the page and don't necessarily need mutual interactions between those visuals, such as cross-filtering, for example, you should simply disable that option. And sometimes I also saw this, sometimes that sync slicer option can be performance killer. If you have many pages in your report and you have many slicers on those pages and you synchronizing slicers between all those pages, sometimes that can also be a reason for the poor performance. Okay, well, maybe I should have placed this thing in the beginning, as decision which storage mode to use is one of the first you need to make when you're starting your Power BI solution. However, I've intentionally left it for the final part of the session, and I think I had a good reason for doing this. I saw a lot of cases when someone thought that the poor report performance can be improved by switching to DirectQuery storage mode and leveraging. The logic is, okay, let's go and leverage capabilities of those robust relational database management systems that are built to cope with massive amounts of data in the most efficient way. That's really wrong assumption. I mean, yes, those systems are built to cope with massive amounts of data in the most efficient way, but in a completely different scenarios, not for Power BI reports. So before I explain why you should avoid using DirectQuery, let me first explain what is a DirectQuery at all. So when you choose DirectQuery storage mode for your tables, this means that your data is being retrieved from the data source at the query time. And this also means that the data resides in its original source before, during, and after the query execution. So nothing goes into Power BI. And thinking that using DirectQuery mode will improve your Power BI report performance is one of the biggest fallacies. DirectQuery will never ever improve performance of the Power BI report, period. So to cut the story short regarding DirectQuery, you should use DirectQuery literally in 3 and only 3 scenarios. First one is your data size is so large that you simply can't import it in Power BI. As we mentioned, for pro licenses, this limit is 1 GB per dataset. For premium, I think this should not be an issue in 99.9% of cases. Next one is requirement to have near real-time reporting solution. So as already explained, when you use import mode, Power BI keeps the snapshot of your data. So data that was imported at specific point in time. And then you refresh that snapshot from time to time. Now let's say that the business requirement is to have data with maximum 1 minute latency. Obviously, you can't refresh data so frequently to satisfy this request. However, don't fall into the trap if your users request real-time data. Is it really necessary? Explain them all the downsides of using DirectQuery mode. And from my experience, many users think of real-time reporting solution like, okay, it's fine to have data refreshed once per day. That's real-time data for me. So in 99% of cases, users will understand the possible downsides and will admit that maybe they don't really need 1 minute latency in their analytic reports, of course. Third one, security policies are defined on the data source side as in those situations, report consumers' credentials will be propagated directly to the underlying data source, and security rules will be applied there. If I still didn't convince you to avoid DirectQuery, or you simply must go this way because one of those 3 reasons we already mentioned, here is the list of general rules that you should keep in mind in order to get the maximum performance from DirectQuery storage mode. The first one is one huge if. So if you have permissions to perform changes on the data source, or if you have access to someone who can do this for you, there are multiple ways to improve the DirectQuery performance. First, you can create proper indexes to support most frequently run queries. Also, you should ensure that data integrity is in place. Nevertheless, of Power BI, that's the general request. Finally, if possible, create a persistent data objects in the database, such as tables, or even better, materialized views, which will persist all the necessary transformations and calculations, and then you're just targeting one single materialized view. If you don't have access to an underlying database, you can still gain some improvement within Power BI itself. The most important thing, avoid using complex Power Query transformations as the SQL that is being generated by the mashup engine. It's correct SQL, but it's not always the most optimal one. If you need to use calculated columns, try to push their creation on the source database and keep them persistent. That will significantly improve the performance. Also, avoid complex DAX measures. First of all, not all DAX measures can be translated to DAX functions can be translated to a SQL. So keep in mind that this process can produce expensive SQL queries for those functions that can be translated. And if you're writing some complex DAX, that will significantly impact the performance of the calculations. And again, whenever possible, do your calculations on the source side. Avoid relationship on GUID columns. So what GUID is, for those of you who maybe are not aware, GUID is a specific data type in relational databases, unique identifier. Power BI doesn't support this data type, and it needs to do some internal data conversion during the query execution, and that will affect the performance. The solution for this challenge is to convert this data type within the source database to a string or something similar, and before Power BI generates its own queries. Next one, limit parallelism whenever possible. So you can go and define the maximum number of connections that DirectQuery can open at the same time. So let me show you how it's done. If you go to File, Options and Settings, and Options. Okay, so under Current File, there Publish Dataset Settings. Here you can define maximum connections per data source that can be open at the same time. There are also some additional optimization options in the query reduction tab here. So basically, you can add an apply button to each slicer to apply changes when you're ready, and don't instantly apply all slicer changes, because every time slicer will generate the query to data source, even those slicers which haven't changed. So keep that in mind also. Then you should check assume referential integrity option. What's that? Now imagine, okay, now I have only imported import mode here, but if I open this relationship, I will open properties of this relationship, and you see this small checkbox here, assume referential integrity. It's grayed out now because I'm not using DirectQuery, but when you are using DirectQuery mode, this one will be enabled. So you can click on this, and you should check this option here. Why is that important? Because in that case, Power BI will generate queries which are using inner joins instead of left outer joins, which in theory should be faster and more performant. To conclude, the best practice regarding DirectQuery storage mode is avoid DirectQuery if possible. Okay, so we covered a lot, and except those demos, I think I will fix this later. But let's wrap up the key takeaways from today's session. Or I call this Monday to-do list, but because today is Thursday, you can call it Friday to-do list. So things that you can apply immediately tomorrow when you go to your office and turn on your PC and Power BI. So the key thing is to identify which part or which parts of your Power BI solution don't perform well. If your data model size is large, consider removing unnecessary rows and columns, and try to reduce column cardinality, for example, by removing time portion from your timestamp columns. If your data refresh process takes a while, check if the query folding is in place. In case that you identify the steps that breaks query folding, try to push that step down this transformation pipeline as much as possible. Next, be mindful when you write text to enhance your data model with additional columns and measures. Remember, if you need to filter the data, always filter columns, not whole tables. If your report page renders slowly, try to reduce the number of visuals on it. Use Performance Analyzer. That's a very cool feature in Power BI Desktop to identify the bottlenecks, and don't use many visuals that calculate single value, such as card visuals, for example. Finally, stay away from DirectQuery storage mode if possible, and use it only in those 3 scenarios we've already discussed. Now, you should keep in mind, of course, each of these points, but if you ask me, one of them is slightly more significant, and that is the number 1. Why? Identifying which part of your Power BI solution is the root of the performance issues will help you to concentrate and focus on solving a specific problem rather than wasting time on less important stuff. That's it from me. I promise to try to fix those 2 demos for query folding and for cardinality. And yeah, you know what they say, the road to hell is paved with good intentions. So now that you know what are some of the deadly sins when it comes to Power BI performance, you may get your redemption by avoiding to commit them again.
Well, thank you very much, Nikola. It was a great session, and I'm sure everybody learned a lot. The key takeaways were really good, and I hope everybody will start implementing them tomorrow. We had very few questions during the session, and one of them was related to query folding. Was incremental refresh not working is one of the consequences of not applying query folding also, right?
Yeah, not always, but it could be. So if you're using incremental refresh and you break query folding, you will still your data refresh process will work, but it will not be incremental refresh. So it will be refreshed completely. So basically, you are losing the main purpose of incremental refresh. So because the whole portion of data will be loaded. So query folding will not stop data refresh process if you're using incremental refresh, but you lose incremental refresh advantage. Yeah.
Okay. So as Fernando was saying, it
demo
depends.
gods. Yeah, I always pray to them, but no, I messed up this time. So I was playing 2 days ago with SQL Server, shrinking some log files. Completely forgot that I'm using this in this demo. So that's not demo gods. That's I'm an idiot.
Another question was related to that really nice chart visual. It's a matrix, right?
It's a matrix.
The blue one.
Yeah, it's a matrix. I will show you. Let me just. I stopped sharing because I opened the SQL Server Management Studio in the background, but let me show you again. So yeah, this is a matrix. This is a matrix visual. Let me just.
Yeah, it's selected on the visualization.
Yeah, it's a matrix visual, but it's formatted in that way to resemble those cards here. So it's exactly the same, but it's a matrix visual. So with some tweaking here and there, I can share the link. Chris Hamill explained how to from Microsoft. He explained how to format the visual to resemble the card visuals. So basically,
it's custom formatting on the measures also, right?
On the measures, and you need to do some things, some different things like labels and stuff like this. And but it requires some time. But I think in the end it's worth. It's worth because once you set it up properly and configure it properly, so you can reap the benefits. Yeah, because you get the better performance, definitely.
Cool. And I also have a question related to performance. Do you have any insights, or have you tested the impact of hybrid tables in performance? Do you think there are any key points that we should know?
I played around like 2 or 3 weeks ago. Once they put hybrid tables into public preview, I was playing around with also with Contoso dataset. It's not ready for production, so I didn't apply it in some real life scenario. The thing that I don't like with hybrid tables at the moment is that so the logic for people maybe who are not familiar, just to try to explain in few sentences.
Please.
The logic is that the latest partition, which is the latest day, basically if you set incremental refresh to last 24 hours, the latest partition is being targeted using DirectQuery, and historical data, so older data, is in import mode, and you have everything in one table. So you have import mode and DirectQuery mode within one table, and concept is very powerful. And when they announced this in May last year, I was so excited and I was eagerly waiting for this. But the thing I don't like now is that, for example, if you are querying data, only historical data, so no the latest one, still DirectQuery will be generated and sent to a database.
So this is the fourth.
It will
DirectQuery,
return
indirect DirectQuery.
Yeah, because for example, I want data from last 6 months and up until last week, so I don't need DirectQuery at all. But still, DirectQuery is being generated and sent. It will return empty data set, but it's still being generated. So that's I had a talk with Christian Sakovsky. He's working on this feature in Microsoft, and they are working on it to somehow to exclude those queries. And in that case, that would be
it would be great.
Yeah. Now it also works fine, but still has some room for improvement.
This is why it's in preview and not GA yet.
Exactly.
Yeah, we have one more question from Didier.
Mm-hmm.
Thanks, Nikola, for the excellent presentation. Do you think custom visuals executing within the sandbox have a big negative impact on performance?
Oh, I don't know. That's a good question, but honestly, I haven't used custom visuals so much in production, here and there, but I can't say that I'm not a fan, but sometimes it's hard to convince companies that
custom visuals are safe.
Yeah, are safe, and that in 1 year or 2 years they will still get support. Or, if you put them in, like, I don't know, 100 reports, and after 1 year there is no support for this custom visual, 100 reports are broken, so you are in trouble. And that's why I'm avoiding custom visuals. So I think I'm not competent to answer this question. Sorry.
Even with the Microsoft certified custom visuals?
Yeah, that's more safe solution, but still those are certified visuals, but you don't know who will maintain them or support them in 1 year or 2 years. Basically, those are some other companies that's if we are talking about some third-party visuals, not Microsoft developed.
True. Well, thanks again for the presentation. That's it from the question point of view, and we'll go to the raffle for a few minutes. And,
okay, I'll try to fix those
back.
demos. Yes, I try to fix those demos. I'll stay in the background and I'll let you know if I manage to fix it. Just to quickly show what I was talking about. It's much more convincible.
It's easier to see the demo.
Yeah.
Okay, so let's go to the raffle now. We have 9 answers on the form. As I said, the form itself has a flow in the background, which is writing the data in a SharePoint list. I can show you the SharePoint list if you want. Not many people register for this one, so you have the option to enter the raffle or now. And from here, I've built a Power BI report, this one that I'm showing, which is taking the data, and inside this Power BI report, there is a Power Apps, this one, which also triggers flow, which is randomizing the IDs from the SharePoint list. So let's do a refresh again and see if we have all the participants. So the chances are really high for the 8 participants in the raffle, because we have 3 prizes. let's choose the first winner. I hope the flow works. It works, but it doesn't work well because I have a license and I don't want to have another one. So we'll have 3 names from now. So it seems I have a random issue with the flow because the option of not participating in the raffle is not considered. So it's good that I checked it like this. So let's go with the second winner. Christian Prifti, it's the first winner. Congrats, Christy. I'll send you an email after the session to validate the email address and then forward it to the Enterprise DNA. So let's choose another one. Christian Tilihoy. So 3 draws, all of them Christian. We might have something here. Christy Tilihoy. Congrats, Christy. I'll send you an email also after the session. Let's refresh it and go again with the last one. Choose random winner. By Subti. Really cool. Congratulations. So we have our 3 winners. I'll contact you all after the meetup, probably during the day tomorrow, to validate your email addresses. Usually the email addresses that you wrote in the form might not want to be the ones used for the Enterprise DNA membership. So I just want to validate the email addresses and then follow up with Enterprise DNA team. Congratulations to all the winners. And as I said, we'll have a follow-up on this one. Thanks again, everyone, for joining. Thank you, Nikola, for accepting our invitation, and looking forward to see you again on either in our user group or on another user groups. Maybe even in person someday.
Yeah, hopefully. I really hope. Yeah, I really hope.
Yeah, same for me. So thanks again, and thank you, everybody.
Thank you. Thank you. Enjoy the rest of the day or evening.